Last class, 6 questions completed, ma. Now today we'll discuss that 6th, 7th question. Yes, ma, Afzal. Yes, 7th question, let's see, it's very easy. Okay, listen students. 7th question. So in the 7th question, actually I provided that material, that books. Okay, today I will share you that PDF. Anybody want means I will share that questions PDF also. No, don't worry. Now listen that 7th question. In the 7th question, see the wavelength of radiations emitted by He plus. The electrons falls from infinity state. At infinity to stationary state means ground state ma. Stationary state means ground state. Stationary state is nothing but ground state. Okay. Okay, listen. So here infinity state means N2 is equal to infinity state, and the stationary state N1 is equal to 1. So the stationary state is nothing but ground state. Okay, understand? Now the transitions are taking place from infinity state to ground state of He plus, that we have to calculate its wavelength. Excited state means higher energy level states. Excitation means more energy levels. Ground state or lower energy levels means lower levels, N1. So ground state means first energy level. First excited state means second energy level. Third excited state means fourth energy level. Yesterday we are discussed energy levels and all. Again, why you are asking, Mr. Excited state? Excitation means higher energy levels. So first excitation means N is equal to 2. Second excitation means N is equal to 3. Means you are not studying properly. Simply doing charting. Wasting time. So for He plus wavelength we need to calculate. So for hydrogen like species wavelength 1 by lambda is equals to R value is 1,09,677. So R 678, that RH into 1 by N1 square minus 1 by N2 square into Z square. So here N1 is very clear, 1, N2 is equal to infinity. So listen, RH value is equal to 1,09,678. Next, Z for helium. Helium is equal to 4. Okay. And N1 is equals to 1. N2 is equals to infinite state. So 1 by lambda, just substitute the values. Then we have to find out lambda, wavelength. Lambda value we need to find out for this transition. 1,09,678 into 1 by 1 square means 1 minus 1 by 2 square. 1 by n2 square means 1 by infinity square. Z value is 2 whole square. Yes, ma, RH or R value 1.097 into 10 to the power of 7 meter inverse. Otherwise, we have to use this value in centimeter inverse. No problem, whatever it may be. First, we have to convert into that meters. That meters, centimeters value, we have to convert into meters. Okay. Otherwise, directly the given value you have to use. The given value do you want to use means 1.097 into 10 to the power of 7 meter inverse will comes. But this value is in centimeter inverse. Okay. So the centimeter inverse now is nothing but 1,09,678 into 1 square value is 1 only, 1 by 1 minus infinity, 1 by infinity is nothing but 0 into 2 square is nothing but 4 centimeter inverse. Now is nothing but 1 by lambda is equals to 1,09,678 into 4 centimeter inverse. So the lambda is equals to 1 by 1,09,678 into 4 centimeters is nothing but approximately on simplification this value will comes 2.2 into 10 to the power of minus 6 centimeters, and 1 centimeter is equals to 10 to the power of minus 2 meters. We know that. Then this value is 2.2 into 10 to the power of minus 8 meters. So the correct answer is first one, 2.2 into 10 to the power of minus 8 meters. So here the important formula is 1 by lambda is equal to RH into 1 by n1 square minus 1 by n2 square into z square. What is n1 value? n1 is 1, n2 value is infinity. 1 by infinity square is 0. Is 0. That you have to keep it in your mind. Z value for helium is 2. Helium is 2. Then 1 by lambda is equal to 1,09,678 into 4 units are centimeter inverse. Now the lambda value will come under centimeters. How many centimeters came? 2.2 into 10 to the power of minus 6 came. Then that actually options they are given in meters. That's why we have to convert centimeters. We have to convert into meters. That is 2.2 into 10 to the power of minus 8 meters. Okay. So it is very easy, ma. Understood? Everyone? Clear? Nischal? Let inform me immediately. Nischal. Yes, ma. Okay. Okay. Go for next question. While I am explaining the question, don't do any messages. Okay. Let's listen next question, ma. It's very easy. Here one important shortcut. We can by using that shortcut we can explain this question very easily. Let's see what is that shortcut. In Bohr series of lines, hydrogen spectrum. Okay, third line of red end. Red end means red color end. Means the spectral lines are present in visible region. Okay, spectral lines are present in visible region means it is Balmer series. So we know that Balmer series n1 value is 2, it is fixed. So we have to identify n2. N2 value we need to identify. For identification of N2 value, they gave one hint, that is the transitions is present in third line. From third line to second line, it is happened. N is equal to 2. Sorry, N1 is equal to 2, it is happened. So that energy levels, first you draw the energy levels. Okay, now these are the energy levels. Now this is energy increasing order. N is equals to 1, it is 2, it is 3, 4, 5, 6, 7, like up to infinity state. Okay, now for required N1 is equals to 1, that is Balmer series. So all the transitions from higher energy level are excited state to lower state. N1 is equals to 2. Sorry. N1 is equals to 2, that is Balmer series. Balmer series. So this is the first line. First line. So 3 to 2. 3 to 2 is first line. But they're asked third line, what is the transition for third line? 4 to 2 is second line. 5 to 2 is third line. So the transition is 5 to 2. This is the third line. So N2 is equals to 5. Then N1 is equals to 2. Then the transition is third line of Balmer series. Okay, clear? Yes, ma'am. Understand? So it's very easy. Now they gave hint. This transition is belongs to either Lyman series or Balmer series or fashion series or bracket or fund series. They gave one hint is the lines are appearing in red and. Red and means it is belongs to visible region. Visible region means Balmer series. In the Balmer series, the first line N1 is fixed. N1 is 2 only always. So higher energy state, how to identify that higher energy state? They gave hint, the transition is present in third line. Third line means N2 is 5. Third line means N2 is 5. Third line means third excited state. So in Balmer series, first excited state is 3. Second excited state is 4. Third excited state is 5. Okay, clear? Yes, ma, observe. Okay, let's go for ninth question. See, listen, ninth question ma, very easy. The corresponding energy differences they give. Delta E values, E2 minus E1, E3 minus E2, E4 minus E3, like different, that correct energy order we need to explain. We need to calculate. We need to calculate. So for this hint is, these all are the energy differences, alternative energy differences only. 1, 2, 3. Let's see. 1, 2, 3, 4 they gave. 1, 2, 3, 4. See, this is the first energy difference. 1, 2, 3, 4. This is delta E1. This is the second energy difference. Delta E2. And successive energy differences ma, delta E3. Okay, in that always this delta E1 is more than delta E2 and then delta E3. So that is the shortcut ma, you have to remember. So how I said means in alternative energy levels, alternative energy levels, the energy difference value decreases, then increasing the distance from nucleus. Okay, see, it is the nucleus. You have to remember the energy levels, means it is shell numbers only. 1, 2, 3, 4, like it is a 1, 2, 3, 4. This is delta E1, this is delta E2, and this is delta E3. So the in successive energy differences in alternative energy levels, 1 after 2, 2 after 3, 3 after 4, 4 after 5, maybe 5 you have to take, then this 5, that energy difference between 5 to 4, that is delta E4, that is less when compared to delta E3, because that in alternative energy levels the energy difference value decreases with increasing the distance from the nucleus, means n value increases, then distance from the nucleus increases, then the energy difference value is decreases. So according to that, E2 minus E1 value is more when compared to that E3 minus E2 value, and then E4 minus E3, and then also we can write E5 minus E4 also we can write. So like that, next also we can write one more energy, that is E6 minus E5. Okay, that is the shortcut ma. So theoretically, do you want to calculate that energy differences between E1 minus E2, E3 minus E2, or E4 minus E3, then also that always E1 minus E2 value will be more when compared to that E2 minus E3, because in every energy level difference, the number of lines, how many are there? One only, means 1 and 2 difference, 2 and 3 difference, 3 and 4 difference, 4 and 5 difference, 5 and 6 difference, 6 and 7 energy difference, 7 and 8 energy difference. In between that, how many energy levels are there? The one energy level only present. So in successive energy differences, E2 minus E3 means the energy difference between the second level to third level, or energy difference between third energy state to second energy state. E2 minus E1 means the energy difference between second energy level minus first energy level. So that value will be always more when compared that this delta E2, when compared the delta E3, when compared the delta E4, when compared the delta E5. Understand? So according to that, first option is correct. Energy order. Let's see another method also. I have to solve this question. We know that energy En value in electron volts minus 13.6 into Z square by N square. So for hydrogen atom, En is equals to minus 13.6 into 1 by N1 N square electron volts. Okay, it is very clear. Now the E1, E2 minus E1 value you have to find out. That means N is equal to 2, N is equal to 1, then the value is 13.6 into 1 by 13.6 into 1 by 1 minus 1 by 4, 1 by 2 whole square is equal to 13.6 into 3 by 4. 3 by 4 is nothing but 13.6 into 13.6 into 0.75 electron volts. Okay, just let it. Now the second one you have to calculate. The second one is E3 minus E2. E3 minus E2, the energy difference is 13.6 into 1 by 2 square means 1 by 4 minus 1 by 3 square means 1 by 9. Then is nothing but 13.6 into 9 minus 4 is nothing but 5 by 36. If you have to simplify this, 13.6 into 5 by 36 value is 0.13 electron volts. Next, the third one is E4 minus E3. You have to calculate E4 minus E3, then 13.6 into 1 by 3 whole square means 1 by 9 minus 1 by 4 whole square is nothing but 1 by 16. Then the LCM is 9 into 16. Then 16 minus 9 is equal to 16 minus 9 is equal to 7. Means 13.6 into 7 by 16, 9 ja 144. This is on simplification. We will get 13.6 into approximately 0.04 electron volts. If you are observed that it is 13 into 0.75, it is more. So therefore, it is more value than second 13.6 into 0.13, and the third one is 13.6 into 0.04. That's why 1 is more than 2 and then 3. Means the energy difference between E2 minus E1 is more than E3 minus E2 and then E4 minus E3. So this is theoretically or experimentally based on the formula based we are solved. It takes more time. But whenever this kind of question they are asked means what is that shortcut method ma? In successive energy differences in alternative energy levels they gave, and that energy difference increases from the nucleus. The energy difference value decreases then increasing the distance from the nucleus. That's why this is E2 minus E1 is nearer to the nucleus, then E3 minus E2, then E4 minus E3, like E5 minus E4, then E6. So we can make so many orders. E6 minus E5, like, okay. So understand, clear for all? Afjal, Rani, clear? Okay, let's see next question. So here, without solving this all, means without calculating the E2 minus E1 value, E3 minus E2 value, E4 minus E3 value, just while seeing the options only we can say. How to say? Already I said that hint. What is that hint? The energy difference value decreases when the increasing distance from the nucleus, when the alternative energy levels they give. If alternative energy levels are present, the energy difference value decreases when increasing from the nucleus, distance increasing from the nucleus. Okay, very clear. Let's see next question. 10th question ma. See, in which of the following electronic transitions of hydrogen atom will requires largest amount of energy? See, this is also energy differences only. N1 is equal to 2. So this is also energy differences only ma. So for this, how to solve? Means N1 is equal to 1 means E1. Then this is E2. Is nothing but E2 minus E1 value. This is nothing but E3 minus E2 value. This is nothing but E1, E infinity level to E1. This is E5 minus E3. Observe, option 1 is not correct. See, this n is equal to 1 to 2. In between, how many number of lines are present? Only no energy levels are present. So the energy gap is less. Energy gap is less because these are not alternative energy levels. E2 minus E3 means 2, 3. This is also in between. There is no energy levels. So compare that 1 and 2. 1 is more energy. Now come to that 1, 2, 3, 4, 5, 6 up to infinity. It is 1. So this energy gap is more. Energy gap is more. Now 5 to 3, the energy gap. One, two, three, 4, 5. 5 to 3 means in between the energy gap, one energy levels is present. So one energy level is present in between. So compare that all, the energy gap is increases. So here shortcut is energy levels. Gap increases, delta E value, the energy difference value is increases. According that more energy gap is present from 1 to infinity. 1 to infinity, that's why it has more energy. Next, the correct order is third one is more because the third one has more energy gap. Next, fourth one. Next, 1 and 2 there is no energy gap, but we know that 1 and 2 options E2 minus E1 and E3 minus E2 both are successive alternative energy levels. In that alternative energy levels, the distance increases, the energy will be decreases. That's why the first one is more when compared to second one. This is the energy order. So highest energy gap or large amount of energy is present in between n is equal to 1 to n is equal to infinity because in between that more energy levels are present. E5 to E3 in between one energy level is present. E3 to E2 there is no energy levels in between only no energy levels. Okay, because they are alternative energy levels. In alternative energy levels the energy gap is 0. Okay, so in alternative energy levels energy gap is 0, then the distance from the nucleus increases, then the energy will be decreases. But if without there is no alternative energy levels, more energy levels are present in between the two energy states, then that energy gap is increases, then the energy difference will be increases. So according to that, third option is correct. Understand? Otherwise, you have to calculate the values theoretically. Already I said how to calculate the energy difference between E2 minus E1 and E3 minus E2 and E infinity to E1 and E5 minus E3. That values you have to calculate. Then highest value will comes for E infinity to E1. Okay, go for next question. This is very, very important, ma. These formulas we are not discussed. Let's see. Now I will discuss that very, very important formulas. According to Bohr theory, the electrons are revolves around the nucleus. Okay. in stationary orbits. This is stationary orbits. Or stationary waves. So in this case, what they ask, the time taken by the electrons in one complete revolution of nth orbit of hydrogen atom. They are asked, so for this case, let's see 11th one, the time taken for nth orbit Tn is equals to circumference of the circle. Orbit by velocity of electron present in nth orbit. Means we know that formula time is equals to distance by velocity. Distance by velocity. According that, distance is nothing but this orbit circle. What is that? Distance of a circle or circumference of the circle, 2 pi rn. Because it is nth orbit, its circumference is equal to 2 pi rn, and velocity of electron in nth orbit vn. We know that the formulas. What is the formula? Rn, radius of nth orbit, Rn is equals to 0.529 into 10 to the power of minus 8 into n square by z centimeters. Okay, and Vn, velocity of electron in nth orbit, is equals to 2.18 into 10 to the power of 8 10 to the power of 8 by n into z centimeter per second. Okay, that is the both formulas you have to substitute, then we'll get the value, that is 2 into pi into Rn value is 0.529 into 10 to the power of minus 8 into n square by z whole by velocity of electron in nth orbit is 2.18 into 10 to the power of 8 by n into z. Now it is in centimeters, it is in centimeter per second. Now the value, the time will comes in seconds. See, if you are observed that these all are the constant, 2, pi value and 0.529, this is 10 to the power of minus 8, here 10 to the power of plus 8, it goes to upside, means 10 to the power of minus 8 will becomes. On simplification, we will get this value is approximately 1.5 into 10 to the power of minus 16 into n cube by z square seconds. So therefore, this is constant. N cube means n is 1 means first orbit, n is equal to 2 means second orbit, n is equal to n means nth orbit. So the required time for electron revolves in nth orbit Tn is directly proportional to n cube, and the Tn is inversely proportional to z square. So directly proportional to n cube. The correct answer is second option. Okay. So here the simplest concept is the time. We know that